NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math video. Today, we'll be exploring an important algebraic identity, the cube of the sum of two terms. The theorem states that for all a and b that belong to the real numbers, the cube of the sum of plus b is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's see how we can prove this step by step. Now, let's begin our proof. We'll start with the left side of the equation, the cube of a plus b. First, we'll rewrite this as a plus b squared multiplied by a plus b. To do this, we're using the property that x to the power of m plus n equals x to the power of m times x to the power of n. In our case, we're writing the cube as the square times the first power. Now, let's expand the squared term a plus b squared. We know that a plus b squared equals a squared plus 2ab plus b squared. So we substitute this into our expression and multiply by a plus b. Now we'll use the distributive property to multiply a plus b by each term in the parentheses. This gives us a squared times a plus a squared times b plus 2ab times plus 2ab times b plus b squared times b. Let's multiply each of these terms. We get a cubed plus a squared b plus 2a squared b plus 2ab squared plus b squared a plus b cubed. Now let's combine like terms. We add a squared b plus 2 a squared b to get 3a squared b. And we add 2ab squared plus b squared a to get 3ab squared. So we're left with a cubed plus 3 a squared b plus 3ab squared plus b cubed. And there we have it. We've successfully proven that the cube of the sum of two terms, a plus b cubed, equals a cubed plus 3a squared b plus 3ab squared plus b cubed. This formula is extremely useful in algebraic expansions and is an example of a binomial expansion. Let's start with our first example. We need to expand x plus 5 cubed. To do this, we'll use the formula we just learned, replacing a with x and b with 5. First, let's substitute a equals x and b equals 5 into our formula. So we get x plus 5 cubed equals x cubed plus 3 times x squared times 5 plus 3 times x times 5 squared plus 5 cubed. Now, let's simplify each term. X cubed remains as x cubed. 3 times x squared times 5 gives us 15x squared. 3 times x times 5 squared is 3 times x times 25, which equals 75x. And 5 cubed equals 125. So our final answer is x cubed plus 15x squared plus 75x plus 125. Let's try another example. This time we need to expand x plus 1 cubed. Again, we use our formula, replacing a with x and b with 1. So we get x plus 1 cubed equals x cubed plus 3 times x squared times 1 plus 3 times x times 1 squared plus 1 cubed. Let's simplify. X cubed remains x cubed. 3 times x squared times 1 equals 3x squared. 3 times x times 1 squared equals 3x. And 1 cubed equals 1. So our final expansion is x cubed plus 3x squared plus 3x plus 1. We want to expand to a plus 1 cubed. To apply our binomial formula, we need to identify the values for a and b. In this case, a equals 2a and b equals 1. Now, let's substitute these values into our binomial formula step by step. First, a cubed is 2a cubed, which equals a cubed. Next, 3a squared b is 3 times 2a squared times 1, which equals 3 times 4 squared, giving us 12a squared. Then, 3ab squared is 3 times 2a times 1 squared, which equals 3 times 2a, giving us 6a. Finally, b cubed is just 1 cubed, which equals 1. So, our final expansion is 8a cubed plus 12a squared plus 6a plus 1. Let's verify this by using the algorithm shown in the image. Now, let's look at our second example. We want to expand x plus 1 over 3 cubed. Again, we identify the values for a and b. Here, a equals x and b equals 1 over 3. Let's apply the binomial formula step by step. First, a cubed is x cubed. Next, 3a squared b is 3 times x squared times 1 over 3, which simplifies to x squared. Then, 3ab squared is 3 times x times 1 over 3 squared, which equals 3 times x times 1 over 9, giving us x over 3. Finally, b cubed is 1 over 3 cubed, which equals 1 over 27. So, our final expansion is x cubed plus x squared plus x over 3 plus 1 over 27. Let's summarize what we've learned. The binomial expansion for a plus b cubed follows the pattern. A cubed plus 3, a squared b plus 3, ab squared plus b cubed. Notice the pattern of coefficients. 1, 3, 3, 1. And the pattern of exponents. The exponent of a decreases from 3 to 0, while the exponent of b increases from 0 to 3. Expand 2a plus 3b, cubed using the binomial cube formula. First, we need to identify what our a and b values are in this expression. In this case, a is 2a and b is 3b. Now, let's apply our binomial cube formula. We substitute a with 2a and b with 3b in our formula. This gives us 2a cubed plus 3 times 2a squared times 3b plus 3 times 2a times 3b squared plus 3b cubed. Next, let's calculate each term individually. The first term is 2a cubed, which equals 8a cubed. For the second term, 2a squared is 4a squared, and we multiply this by 3b and by 3, giving us 36a squared b. For the third term, 3b squared is 9b squared, and we multiply this by 2a and by 3, giving us 54b squared. Finally, the fourth term is 3b cubed, which equals 27b cubed. Let's combine all these terms to get our final answer. Adding everything up, we get 8a cubed plus 36, a squared b plus 54, ab squared plus 27b cubed. And that's our expanded form of 2a plus 3b cubed. Let's look at our second example. Expand x squared plus 1, cubed using the binomial cube formula. First, we need to identify what our a and b values are in this expression. In this case, a is x squared and b is 1. Now, let's apply our binomial cube formula again. We substitute a with x squared and b with 1 in our formula. This gives us x squared cubed plus 3 times x squared times 1 plus 3 times x squared times 1 squared plus 1 cubed. Let's calculate each term individually for this example. The first term is x squared cubed, which equals x to the 6th power. For the second term, x squared is x to the 4th power, and we multiply this by 1 and by 3, giving us 3x to the 4th power. For the third term, 1 squared is just 1, and we multiply this by x squared and by 3, giving us 3x squared. Finally, the fourth term is 1 cubed, which equals 1. Now, let's combine all these terms to get our final answer for the second example. Adding everything up, we get x to the 6th power plus 3x to the 4th power plus 3x squared plus 1. And that's our expanded form of x squared plus 1 cubed. Let's begin solving this step by step. The first thing we need to do is to rewrite our expression in a format where we can apply the binomial theorem. Looking at negative a squared minus 2a cubed, we can factor out the negative sign, which gives us negative times a squared plus 2a cubed. Now we can use the power rule for negative signs. When a negative number is raised to an odd power, the result is negative. Since 3 is an odd number, negative to the power of 3 is negative. Now we need to expand the expression a squared plus 2a cubed using the binomial theorem. According to the binomial theorem, when we have a plus b to the power of n, it equals the sum from k equals 0 to n of n choose k times a to the power of n minus k times b to the power of k. For the special case of the cube, we have a plus b cubed equals a cubed plus 3, a squared b plus 3, ab squared plus b cubed. In our case, a is a squared and b is 2a. Let's substitute these values into the binomial expansion formula. Now let's simplify the exponents in each term. For the first term, a squared cubed becomes a to the power of 6. For the second term, a squared becomes a to the power of 4, and multiplied by 2 becomes 2a to the power of 5. For the third term, a squared times 2 a squared becomes 4a to the power of 4. For the fourth term, 2a cubed becomes 8a cubed. Finally, we need to distribute the negative sign to all terms inside the brackets. This gives us negative a to the power of 6 minus 6a to the power of 5 minus 12a to the power of 4 minus 8a cubed. So our final answer is negative a to the power of 6 minus 6a to the power of 5 minus 12a to the power of 4 minus eta cubed. Now, let's solve our second example. For this second example, we'll directly apply the binomial theorem since we have a sum raised to the power of 3. According to the binomial theorem, we have 3a squared plus 2bc to the power of 3 equals the sum of 4 terms. Now let's simplify each term. The first term becomes 3 cubed times a to the power of 2 cubed, which equals 27a to the power of 6. For the second term, we have 3 times 3 squared times a to the power of 4 times 2bc, which simplifies to 54a to the power of 4bc. The third term becomes 3 times 3a squared times 2bc squared, which equals 36a squared b squared c squared. And finally, the fourth term is 2bc cubed, which is 8b cubed c cubed. Now we can combine all terms to get our final answer. Let's summarize what we've learned about expanding cubic expressions. First, for any expression in the form a plus b cubed, we can use the binomial theorem to expand it as a cubed plus 3a squared b plus 3ab squared plus b cubed. Second, when dealing with negative signs, remember that negative to an odd power is negative and negative to an even power is positive. Third, be careful with the exponents and coefficients when simplifying terms. These examples show how to handle both simple and complex cubic expressions using the binomial theorem. In this video, we'll solve the problem of calculating 105 cubed by using the binomial cube expansion formula. Step 1. We first rewrite 105 cubed as the cube of 100 plus 5. Since 105 is equal to 100 plus 5, we can express the problem as the cube of 100 plus 5. Step 2. To evaluate this, we'll use the binomial cube expansion formula. The binomial cube expansion formula states that for any two numbers a and b, a plus b cubed equals a cubed plus 3 times a squared times b plus 3 times a times b squared plus b cubed. Now we'll apply this formula to our problem, where a equals 100 and b equals 5. Step 3. Let's calculate each term one by one. The first term is 100 cubed, which equals 1 million. The second term is 3 times 100 squared times 5. 100 squared is 10,000, and multiplying by 3 and 5 gives us 150,000. The third term is 3 times 100 times 5 squared. 5 squared is 25, so this term equals 7,500. The fourth term is 5 cubed, which equals 125. Step 4. Finally, we add all four terms together. 1 million plus 150,000 plus 7,500 plus 125 equals 1,157,625. Welcome to this math tutorial. Today, we're going to solve a problem that involves completing a cubic expression. We have a partially filled expression x cubed plus 1 over x cubed. Our goal is to find the missing terms to complete this cubic expression. Looking at this expression, we have two terms x cubed and 1 over x cubed. Notice how these terms are related. One is the reciprocal of the other. When we see this pattern in mathematics, it often suggests using the formula for the cube of a binomial, specifically the cube of the sum x plus 1 over x. Let's recall the formula for the cube of a binomial a plus b. A cubed plus 3a squared b plus 3ab squared plus b cubed. Let's try applying this formula to our problem. If we let it equal x and b equal 1 over x, then a cubed is x cubed, and b cubed is 1 over x cubed, which matches our two known terms. The expansion becomes x cubed plus 3x plus 3 over x plus 1 over x cubed. Here's our problem. We need to fill in the missing terms in the following expression. 8a cubed plus 3a squared plus. Let's follow the solution process shown in the algorithm. Based on the given terms, we can see this is a cubic expansion, meaning it's of the form open parenthesis 2 a plus 1/4 close parenthesis cubed. Let's verify this is correct by looking at the first term. In a binomial expansion of the form open parenthesis x plus y close parenthesis cubed, the first term is x cubed. In our case, that would be open parenthesis 2 a close parenthesis cubed, which equals eta cubed. This matches our first term in the original expression, so we're on the right track. Now let's apply the binomial theorem to expand this expression. In our case, we have open parenthesis 2 a plus 1/4 close parenthesis cubed. So we need to find each term in the expansion. Let's expand this step by step. The full expression is 8 cubed plus 3 squared plus 3/8 plus 1/64. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.